Hey, this video is about molecular formulas that we can derive from empirical formulas. So, first of all, you should be experts now at using percent composition data and getting an empirical formula. Remembering, empirical formula is the simplest whole number ratio of the atoms in a compound. Now, we can get the molecular formula, or the way that the compound actually exists, if we have the empirical formula and if we have the molar mass of the compound. So the subscripts in the molecular substance, they're always a whole number multiple of the subscripts in the empirical formula. So if we had an empirical formula here, C3H4O3. So here's the empirical formula. That's the simplest whole number ratio of those atoms. It's a 3 to 4 to 3 ratio. The molecular formula, it could actually be the same as the empirical formula, or it could be a multiple, so where everything is doubled, C6H8O6, or tripled, C9H12O9, or it could be where each thing was multiplied by 4, C12H16O12. But it's always going to be a whole number multiple of the subscripts of the empirical formula. So how do we know what these empirical subscripts have been multiplied by? Well, to get the whole number multiple, we need to take that molar mass of the compound, and that has to be given to you in the problem. And we are going to just divide it by the molar mass of your empirical formula, which you can figure out. All right, well, let's give this a try. So here's our empirical formula, C3H4O3. Let's go ahead and see what its empirical mass is, which is like formula weight. All right, here we go. We have 3 carbons, each is 12.01, and we have 4 hydrogens, each is 1.01 AMUs, and we have 3 oxygens, and each is 16. So when we do that multiplication and we sum it all together, we come up with 88.07 AMUs. All right, so 3 carbons, 4 hydrogens, 3 oxygens has a mass of 88.07 AMUs. Well, they tell us that the molar mass of this is 176 AMUs. You know, it doesn't match, okay? So what is the molecular formula? Well, what we're going to do is we're going to take that molecular mass of 176 and divide it by our empirical mass, which is 88.07, and we get something around 2. Okay, so see, this is double what our empirical mass was. So now what you do, once you divide that molar mass, which has to be given to you, by the formula weight of your empirical formula, you'll get a whole number ratio. In this case, it's a 2. Now you go back to your empirical formula and you multiply all those subscripts by that number. So it's C, 3 times 2 is 6, H, 4 times 2 is 8, O, 3 times 2 is 6. So that is our molecular formula. That's actually how we find this in nature. It's not the empirical formula, it's not the simplest whole number ratio. C3H4O3 is the empirical formula, but this is the molecular formula. You can check by taking 6 times 12.01, 8 times 1.01, and 6 times 16, and seeing if you actually get something close to 176. Okay, now let's go ahead and practice. All right, in this problem, they've given you the empirical formula, C3H4, and they tell you the molar mass is about 121 AMU. What is the molecular formula? Well, let's see. Let's get the molar mass of our empirical formula. So 3 carbons times 12.01 plus 4 hydrogens, which is 1.01. We put all that together. Let's see if we get 121. I don't think so. I think it's going to be a lot lower than that. And it's actually right around 40 AMU. Okay, so our empirical mass is 40 AMU. And the molar mass of the molecular formula is 121. So take that bigger number, that 121 AMU, that molecular mass, divide it by 40.07, and the whole number you're going to get is somewhere around 3. So the empirical formula is C3H4. The molecular formula is 3 times that. All right, so the molecular formula is C9H12. All right, now sometimes they don't give you the empirical formula. First you have to figure out the empirical formula, and then from there they'll give you the molar mass, and then you have to use your empirical formula that you came up with. So this is good review. Okay, ibuprofen, you know, a real common anti-inflammatory medicine, and it's used for headaches, contains 75.96% carbon, 8.8% hydrogen, and 15.51% oxygen by mass, and it has a molar mass of 206 grams per mole. What's the empirical formula of ibuprofen, and what is the molecular formula of ibuprofen? All right. Well, let's go ahead and start. And remember, with percent composition data, we're going to assume we have 100 grams, and so those percentages turns to grams. 75.69 grams of carbon, and we are going to convert everything to moles by dividing by the molar mass. Our hydrogen, 8.80 grams. 1 mole is 1.01 grams, and oxygen, 1 mole has a mass of 16 grams. Remember I said converting grams to moles was going to become like writing your name second nature? I hope it's starting to become like that for you. All right, so here we go. With our carbon, when we divide the 75.69 by the 12.01, I come up with 6.30 moles of carbon. And with the hydrogen, I come up with 8.71 moles of hydrogen. And for oxygen, when I divide the 15.51 by 16, it's going to be just a little less than 1, and it's 0.969 moles. Okay, do you remember in empirical formulas, after we convert everything to moles, the next step is to divide by the smallest number of moles, which is 0.969. So that's a 1. And then this becomes a 9, and this is going to be about 6.5. Now notice this is not a whole number. We just can't round. So we're going to multiply by an integer until it becomes a whole number. And it looks like if we multiplied it by 2, we'd come up with 13. Whatever we do to 1, we have to do to all. We have to be fair. So we're going to multiply the 9 by 2 and get 18, and the 1 by 2 and get a 2. Our empirical formula is C13H18O2. Okay, so part A is done. We now have our empirical formula. All right, so let's go ahead here and write the empirical formula again. So it was C13H18 and O2. Let's go ahead and get the empirical mass of that. So this is going to be a big one. So we have 13 carbons times 12.01. We have 18 hydrogens times 1.01. And we have 2 oxygens times 16. Yes, that's 16. Sorry about that, guys. That is a 16. There we go. When we add all that together, we get 206. All right, the molar mass is 206 grams per mole. Guess what, guys? The empirical formula and the molecular formula are the same for ibuprofen. So this is the empirical formula and the molecular formula. That can happen. All right, why don't you guys do this practice problem and bring this to class? So I've given you percent composition data. Go ahead and get the empirical formula. It's good to practice. Then I've given you the molar mass, and you need to determine its molecular formula. All right, we'll see you tomorrow.